We're now going to condense logarithms. Sometimes we call that shrinking. Sometimes we call it condensing. So you might see the word shrink the logarithm or condense the logarithm. So what you're looking for is you're looking to see if they have the same base. So natural log of x squared plus natural log of x to the negative 1, those both have the same base. So that base is a base e. And sometimes I just write that base there so I'm reminded until I get used to it. That's a base e. So I'm going to be able to write this as one natural logarithm. And I've got an argument with a positive log. And I have another argument with a positive log. So I'm going to use the product rule, and I'm going to take those two arguments and I'm going to multiply them together. So x squared times x to the negative 1. And this is the product property of logarithms. Then I'm going to just simplify that. X squared times x to the negative 1. Same base, add the exponents. 2 plus negative 1 is 1. And we end up with the natural log of x. So we're going to try a few of these. Here we have log base 7 of u to the 5th minus log base 7 of u squared. So I've got two logarithms. They have the same base. The first is a positive logarithm, and the second is a negative logarithm. So positive logarithms, their arguments go in the numerator, and negative logarithms, their arguments go in the denominator. So we're going to be able to condense these two logarithms because they have the same base. So I'm going to rewrite this as log base 7. And then I know I'm going to have a fraction because I have a positive logarithm and I have a negative logarithm. Now remember, the arguments of positive logarithms go in the numerator and the argument of negative logarithms go in the denominator. So in the numerator, we'll have u to the 5th, and in the denominator, we'll have u squared. U to the 5th over u squared is log base 7 of u cubed. And that's writing it as a single logarithm versus two logarithms. Sometimes your logarithm has a coefficient. So this coefficient is a coefficient of -1. So when you see that negative out there, that's really multiplying the logarithm by a -1. Now I need that -1 to be a positive 1. So what I'm going to do is I'm going to take it and I'm going to move it to the exponent. So if you have anything other than a 1, anything other than a positive 1 that you're multiplying your logarithm by, you're going to take that coefficient and you're going to move it to the exponent. And this would be called the power rule of logarithms. So we'll have log base 5 of x to the -1. X to the -1 is 1 over x. We always write our logarithms, our negative exponents with positive exponents. So we change that negative exponent by bringing it down to the denominator, and we get 1 over x. So we have log base 5 of 1 over x. Okay. Let's try again. This time we have a coefficient of 2/3, and we need to take that 2/3 and move it to the exponent. So we'll have the natural log of x to the 2/3. I can write it like that, or I can put that x to the 2/3 in parentheses. I like to put the argument in parentheses myself. But when it's just a monomial, it's common for you to just write it without the parentheses, so that's fine. So we would have natural log of x to the 2/3, or on an answer key, it'll likely just have x to the 2/3, like that. Just make sure that your 2/3 looks like the exponent that it indeed is. Okay, now in this example, we have 3 logarithms. They all have the same base. They all have a base e, base e, base e. The first one is a positive logarithm, and the next 2 are negative logarithms. So we're going to be able to condense this and write it as the natural log. The argument is going to have a fraction. In the numerator, we're going to have the arguments of all the positive logarithms, which is just an x. And then in the denominator, we will have multiplied together the arguments of all of those logarithms that are negative logarithms. So we'll have a 3 times 2 in the denominator. So we'll have 3 times 2 in the denominator, and we'll have an x in the numerator. X is a positive log. X goes in the numerator. 3 is a negative log, so it goes in the denominator. 2 is an argument of a negative log. It goes in the denominator, so we will have 3 times 2. That is a multiplication symbol. And that will be the natural log of x over 6. Now you can write it like that, or like I do, you can put the parentheses around the argument to make it very clear what the argument is. Now we're going to combine the 2 ideas. So we're going to, before we actually combine and make our single logarithm, we're going to have to make sure that we've got that coefficient of 1 first for each of our logarithms. So on the first one, we have a coefficient of 1, but on the second one, we have to take this 2 and we have to move it to the exponent. So we have log base 8 of 5 plus log base 8 of y squared. Now we've got a positive log, a positive log. I'll be able to write this as 1 logarithm with a base 8, and then I don't have a fraction because they're both positive. I'll be multiplying the 5 and the y squared together, which would be log base 8 of 5y squared. Why don't you go ahead and try this one? Press pause, and at the very minimum, try and take that 3/2 power up to the top, 1/2 power over to the top or the exponent, and then maybe press play and see if you've got it right. Okay, we've got log base 6 of a to the 3/2 plus log base 6 of c to the 1/2. Now that's both a square root. So they're both a square root right here. So we're going to be able to rewrite this log base 6. And then because they're both positive logarithms, we're going to take a to the 3/2, c to the 1/2. And because they're both a square root, I'm going to rewrite this log base 6 of the square root of a cubed c to the 1st. So let me show you what happened here. The a cubed, c to the 1st, c to the 1st, and then the square root is right there. So that would be our answer. Log base 6 of the square root of a cubed c. Okay, we have another problem here. We've got log of y plus 2 log of x plus 2 minus 5 log of z. These are all a base 10, base 10, base 10. The first is a positive logarithm. That's great. The second one is a positive logarithm, but it's got this 2, so I'm going to have to bring that 2 to an exponent. The next is a negative logarithm, which is fine, but the 5 is going to have to go to the exponent. So we're going to have log base 10 of y plus log base 10 of x plus 2 squared minus log base 10 of z to the 5th power. Now I'm going to rewrite this as a log base 10, and I am going to have a fraction here. In the numerator, we'll have the y and the x plus 2 squared, and we'll multiply those two together, and in the denominator, we'll have z to the 5th. Y, x plus 2 quantity squared, and then z to the 5th. And that will be our final answer. So we have written this as a single logarithm with a coefficient of 1. Okay, you try the next and see if you've got it, and then come back and check your answer. Okay, for this, my first step was to take that 1/2 and bring it to the exponent, and then bring the 3 to the exponent. They're both log base 10. I've got a positive log and a negative log, so I'm going to have a fraction. The x plus 1 to the 1/2 goes in the numerator. X cubed goes in the denominator. And then my final step is to rewrite this as a radical. And that's going to be log, and then my fraction bar. I'm going to put parentheses around it as well. The square root of x plus 1 over x cubed. And remember, I don't have a subscript. I don't have a subscript of 10 right there because it's the common logarithm. If that subscript is missing, that means that we're working with a base 10. Now we've got a couple of challenge problems. So we've got 1/3 times the quantity 2 times the log of x plus 2 minus the log of x minus 5. I'm going to work in the parentheses first. So I'm going to take this 2 and I'm going to make it an exponent. So I'm going to have 1/3 on the outside, and then I'm going to have log of x plus 2 squared minus log of x minus 5. So we're going to take little baby steps. Again, I'm going to work on the inside here, and I'm going to condense these. I have a positive log and a negative log, so I'm going to have a fraction for an argument. I'm going to have log and then a fraction bar. In the numerator, we have x plus 2 quantity squared, and in the denominator, we have x minus 5. Now I've got to take that 1/3 power, and I've got to bring it to the exponent. So I'll have log, and then I've got x plus 2 quantity squared over x minus 5. And then that's all raised to the 1/3 power. And the 1/3 power is a cubed root. So that's going to be log of the cubed root. And then inside that cubed root, we'll have x plus 2 quantity squared over x minus 5. A bit of a challenge. And now we're going to try and write this as a single logarithm with a coefficient of 1, but I only have one logarithm that I'm seeing. So I see that this is a log base 2. So I'm going to go slow. I'm going to say, okay, let's just leave that 1 there. Let's just leave that 1 there, and let's bring the 4 to the exponent. So now I've got log base 2 of the square root of x, and then that's going to be raised to the 4th power. Now the square root of x to the 4th power, there's a couple of ways we can do this. You can take the square root of x times the square root of x times the square root of x times the square root of x. Or you can take that square root and make it a 1/2 power and then raise it to the 4th power. Now we're going to use our power to a power rule, and we'll have 1/2 times 4 is 2. So I have 1 plus log base 2 of x squared. Now to make this 1 a logarithm, I'm going to use one of those basic formulas. I want a base 2, so log base 2 of 2 is the same thing as 1. And that's one of our basic properties. I've got a positive log and a positive log, so I can rewrite this as log base 2. I'm going to take the argument and the argument, and I'm going to multiply them together, and I get 2x squared. Log base 2 of 2x squared. So I would recommend studying those basic properties and then the specific properties, and then just persevering through and trying to expand and condense those logarithms using those properties.